6 lessons. Please do well to subscribe to the channel if you haven't subscribed. Welcome to today's live class. If you haven't subscribed to the channel, subscribe to the channel, smash a like on the video, and let's begin. Give us your good comments. We expect to see that, and we expect to get your good comments on the questions we had asked previously and the videos we've made previously. So thank you from all over the world. Welcome to GR of Mathematics. Please, in today's class, please take note that we shall be solving problems on differentiation. We shall be showing you how to differentiate functions. Okay, we shall be showing you how to differentiate functions using the first principle of differentiation. Of course, it continues from the class we had previously on how to solve problems on differentiation, how to differentiate functions. So please, let's begin with an oversight in my last video, problem 9 in particular. So let's go over to problem 9. If you go towards the end of that video, you will discover that in problem 9, the second to the last line thereabout, there was a challenge or an oversight in factorizing the last line. So we shall look at that and then commence from 11 down to a good number of questions. So let's begin. Quickly, for problem 9, we are asked to differentiate the function y equals 1 plus x plus 1 over x, okay, using first principle. So please, I would want you to pay attention and watch this video keenly so that you would understand what is being done. Now, the first step we took was to increase our dependent variable by changing y, which comes from increasing this, our independent variable, by changing x, okay? So an infinitesimal change in the independent variable will cause a corresponding infinitesimal change in the dependent variable. So now, having done that, we would I would simplify again. This is obviously over 1, so I'm going to make this. Permit me to write this as x squared plus 1 over x when you take the LCM, and you could even do this better by implementing the same thing. So using this, you could have x plus change in x all squared plus 1 all over x plus change in x. So when your independent variable changes by an infinitesimal change, it will cause a corresponding infinitesimal change in the dependent variable. I hope that is clear enough. Now, that means that we can now go ahead to make change in y, the change in the dependent variable, the subject of formula, and that will be x plus change in x all squared plus 1 over x plus change in x minus y. But take note, you were told that y is equal to this when simplified. So I'm going to put in place of y what the actual expression is. So I'm going to put this minus y means minus x squared plus 1 all over x. Okay? So the next step would be to simplify further. Let's quickly do that. So simplifying further, I would expand this. This will give me, if I expand, I'll have x squared plus 2x change in x plus change in x all squared plus 1 all over x plus change in x minus x squared plus 1. Okay? So the next step we shall take, let's go further, is the LCM. The LCM of changing x plus change in x and x will give us x in bracket x plus change in x, and that would mean having changing x plus change in x into this LCM gives x, and x multiplies this particular term to give us x squared, x in bracket x squared, all we have here. Okay? Now, on the other hand, when x goes into the LCM, we end up having x plus change in x multiplying x squared plus 1. Okay? Now, let's come over here to continue the problem. So I'm going to bring the problem over here. I hope this is clear enough. Okay, good. Okay, so Now the next thing I'm going to do, pardon that interruption. So the next thing I'm going to do is this. I'm going to simplify further by doing this. Changing y will be equal to expanding that. Let me bring this further, okay? So I'm going to expand that numerator. Now x opens up that bracket to give us x cubed plus 2x squared changing x. Multiplying the other one, it gives us x changing x all squared plus x. Now, coming over to the other bracket, you end up having x multiplying x squared to give us x cubed. X multiplies 1 to give us x. And changing x multiplies x squared to give us changing x times x squared. Then changing x multiplies the last term 1 to give us changing x. So that's what we are going to have all over x in bracket x plus changing x. Okay? So this is problem 9 we had actually looked at. We are revisiting it. So this will give us changing y equals x cubed plus 2x squared changing x plus x changing x all squared minus x or plus x, and minus opens up the bracket to give us minus x cubed. Minus opens this to give us minus x. This becomes minus x squared changing x. Let me write it in this manner. Then minus changing x. Now, at this point in time, we can now simplify taking like terms. So I'm going to cancel out this minus this goes. So x minus x also goes. So we are going to end up having changing y equals 2x squared changing x. You will notice can actually minus this, and you end up having x squared changing x. Then plus x in bracket changing x all squared. So this comes down minus changing x all over x in bracket x plus change in x. Now at this point in time, we could go a step further by bringing out changing x, which is common to every term in the numerator, and that will give us x squared plus x changing x plus or minus 1 all over x squared plus x changing x when you expand the denominator. So now that I've done that, I'm going to move a step further by taking my gradient function. Your gradient function is you taking the differential or the increment rather, changing y and dividing that by the increment changing x. So that would mean using multiplying this result. That would mean multiplying this result here by 1 over changing x. Now when you do that, this cancels out. Changing x cancels what you have in the numerator, and you end up having changing y over changing x equals x squared plus x changing x minus 1 all over x squared plus x change in x. Now, we were not asked to find the gradient function. What we were rather asked to find was the y, the x, the derivative. And I've told you, the derivative is simply taking the limiting value as changing x tends to 0 of your gradient function. So when you take the limiting value of your gradient function, it gives you the derivative of the function. And in that case, taking the derivative, which implies taking the relative value of your gradient function, means that wherever you find changing x in your gradient function, all you have to do is substitute for 0. So I'm going to put 0 wherever I find changing x. So that will give me x squared plus x times 0 minus 1 all over x squared plus x times 0. And that gives me the final result, which is x squared minus 1 all over x squared. So this will be the y dx. Now, in what line did we make that mistake in the previous class? It was actually in this line. So from here downward was where we made that mistake in factorization. So please take note. You could go back to the video we made earlier on, our first video on how to obtain the difference and the derivative of a function. You will find that mistake, so do correct that. My apologies for that. Now let's go to where we should begin today. And where we should actually begin today is problem 11. Okay, so we had solved in the previous video problem 9, 1 to 10 rather, but we made a little mistake in problem 9, and that's why I'm solving it all over again. So let's begin with problem 11. So problem 11 is all about finding, in problem 11, we are asked to find the derivative of this function. We are asked to find the derivative of this function with respect to x using first principle of differentiation. So I'm going to write out this function, what we've been given here. I'm going to write it out as 4 over x squared minus 2, which translates to 4 minus 2x squared over x squared. Okay? Now, what have I done here? Just in case you may not follow what was done here, take note, I used this, that is, I used this particular law of indices. A raised to power minus n is equal to 1 over a raised to power n. That was what I used in simplifying this to get this, so minus 2. Now, I found the LCM at this point. Hope you know that 2 is the same thing as 2 over 1. So the LCM of x squared and 1 gives x squared, and x squared into x squared gives 1. 1 times 4 gives 4. 1 into x squared gives x squared, and x squared times minus 2 gives you minus 2x squared. So the essence of writing this function in terms of this is me preparing the function for what I want to do next. Now, so the function I'm going to be working with for my first principle, for implementing my first principle of differentiation, will be this function. So what am I going to do? In step 1, I'm going to increase y by change in y, which comes obviously from increasing x by change in x. So I'm going to increase y by change in y, which comes from this. Okay? So in the next step, what I'm going to do will be to make change in y my subject of formula. And that would mean taking y to this other side, as the right hand side, and that will give me the next line. That will give me this. Okay? But obviously, y, if you take note of the fact that y, we are told, is, we were told y has been expressed as this. So I'm going to put in place of y, I'm going to put minus 4 minus 2x squared all over x squared. Hope we are good. Now, at this point, let's further simplify the problem. Let's simplify the problem further. So, okay, so let's simplify the problem further by doing this. Now, if we have change in y here, the LCM of x squared and x plus change in x all squared will be x squared, x plus change in x all squared. Now, if x squared plus change in x all squared goes into that LCM, it leaves us with x squared, and x squared would go into 4 minus 2 in bracket x plus change in x all squared close bracket. Okay? And if x squared goes into this LCM, we'll be left with x plus change in x all squared, and that would multiply what we have here. Okay? Now, the next thing I'm going to be doing will be this. The next thing I'm going to do will be to expand. So, I'm going to bring this, I'm going to expand what's in this bracket by doing this 2 in bracket x squared plus 2x change in x plus change in x all squared. Now, what I'm doing here at the moment is to expand x plus change in x all squared within this bracket, and that's what I've done. So, just to make sure that we don't skip any step. So, permit me to clean this off so as to have more space for what we are going to be doing. Now, over here, I would come over with doing this. I would expand that x squared plus 2x change in x. You can check out this expansion, please. All over x squared x plus change in x all squared. So please check out the expansion just to verify. Now, change in y will now give us x squared in bracket. I'm going to use 2 to open up this bracket. So I'm going to have 4 minus 2x squared minus 2 times this will give us minus 4x change in x, and minus 2 times the last term will give us minus 2 change in x all squared. Okay? So I'm going to close this bracket, then come over here. Now, here I'm going to use 4 to expand this bracket. That will give us 4 times x squared is 4x squared. 4 times 2x will give me 8x change in x here. 4 times the last term will give us 4 change in x all squared. Then minus 2. Use minus 2x squared to open up the bracket. Minus 2x times x squared, minus 2x squared times x squared will give us minus 2 raised to the power 4. Minus 2x squared times 2x change in x will give us minus 4x cubed change in x. And minus 2x squared multiplying the last term will give us minus 2x squared change in x all squared. Okay? So, and that will be all over x squared x plus change in x all squared. Now, again, let me clean off this. So, at this point in time, I'm going to use x squared to open up that bracket. So I'm going to have here 4x squared times this. It gives me minus 2x raised to the power 4. X squared times this gives me minus 4x cubed change in x. X squared times this gives me minus 2x squared change in x all squared. Minus, then minus times 4x squared, when you use this minus to open up the bracket, gives you minus 4x squared minus 8x change in x minus 4 change in x all squared minus plus 2x raised to the power 4 plus 4x cubed change in x, and then plus 2x squared change in x all squared. All these over x squared x plus change in x all squared. Okay? Let me go with these. Now, at this point in time, certain things will cancel out. Okay? So certain things will cancel out, and this 4x squared minus 4x squared goes. Okay? Minus 2x raised to the power 4 will cancel, plus 2x raised to the power 4. What else can go away? Let's see. Now we have 4x cubed. There is no, okay. Now minus 4x cubed change in x will actually cancel out 4x cubed change in x. Then let's see again. What then do we have? We have this minus 2x squared change in x squared will cancel out the last term, 2x squared change in x, and we'll be left with minus 8x in bracket change in x, that is this, and this, minus 4 change in x all squared, all over x squared in bracket x plus change in x all squared. Now, I could factorize. Remember, we are still on change in y. Now, I could factorize. In the numerator, notice that you have change in x common, and I could bring out change in x, and you also have 4, minus 4 common. So I'm going to bring out minus 4 change in x. If minus 4 change in x comes out from the first term, I'm going to have, what will be left will be 2x. And if minus 4 change in x comes out from the second term, I'm going to have plus 1 plus change in x. That's what I'm going to have. Okay? All these over x squared in bracket x plus change in x all squared. Now, let's bring the problem over here. Let's continue the problem over here. So I'm going to get my differential, my gradient function rather, sorry. So by dividing change in y by change in x. Once you divide change in y by change in x, it gives you minus 4 change in x, 2x plus change in x. That is our final result here. Our final result here would have to multiply 1 over change in x, because at this point in time we are now obtaining our gradient function, and your gradient function, please take note, is obtained by dividing change in y by change in x. So that is the same thing as multiplying your result by 1 over change in x. Now this change in x will cancel this change in x, leaving you with minus 4 in bracket 2x plus change in x all over x squared in bracket x plus change in x all squared. Now this will be the final result for your gradient function. So what then is the y, the x? The y, the x is you taking the limiting value as change in x tends to 0 of change in y all over change in x. So all you have to do to get the y, the x is to put change in x as 0 in this last expression of your gradient function. So I'm going to do that. When this becomes 0, I will end up having 2x, which multiplies minus 4 to give us minus 8x. And when change in x is put as 0 here, you end up having x plus 0 squared, which is x squared, and x squared will multiply x squared to give us x raised to power 4. Of course, you can cancel that to give you a final result, minus 8 over x cubed. Okay? So, now, that is for problem 11. Let's now move over to problem 12. Now, this will be the last problem we will be taking on first principle of differentiation. Let's move over to problem 12. Now, from problem 12, I will be going straight to differentiating without first principle of differentiation. Now, for problem 12, you are asked to differentiate these. Please take note, we shall be using the technique of term-wise differentiation. In term-wise differentiation, all you have to do is to differentiate a polynomial function or any function given to you term by term. And take note, this is a polynomial function, the sum of separate terms of positive powers in a specified variable. So in this case, please take note, it is a polynomial function. Differentiating a constant gives you 0. Differentiating a linear term gives you the coefficient of the variable in that linear term. So please hold on to that. Now, if y, please remember this, if y is equal to c, the y, the x will be equal to 0. Okay? So let me have the blue marker, please. Thank you very much. Now, so please hold on to the simple rules we shall be using to solve this problem. If y is a constant, then the derivative of y with respect to x will be 0. If y is equal to ax, then the y dx, please take note, will be equal to a. And if you are to differentiate a function like this, please take note, that is, if y is equal to ax raised to power n, then the y dx will be equal to the power multiplying the coefficients, giving you an x raised to power n minus 1. So please take note of this rule, and this rule. We shall be using them in solving this problem. But take note, in solving this problem, we shall be using term-wise differentiation, which requires you to differentiate term by term. Now, so I'm going to obtain the y dx using those rules as follows. Now, using the last rule, differentiating 3x raised to power 4 means using 4 the power to multiply the coefficient, which is 12. Write down your x and subtract 1 from the power, that will give you 3. Coming over, we shall use the last rule again to differentiate this. The power is 3, the coefficient is minus 2. Use the power to multiply the coefficient, that will give you minus 6. 3 times minus 2. Subtract 1 from the power to give you 2. Then, this is differentiating with the second rule here. When y is equal to ax, the y dx is the coefficient a. So this will give me 7. And differentiating this, differentiating 5. 5 is a constant. Differentiating 5 gives you 0. So once you differentiate this function, your result will be this. It is as simple as that. Now let's go over to question 13. For question 13, we are given the function y equals 8x cubed minus 5x squared plus 6 to differentiate. I'm going to leave these rules here. They will help us in differentiating. So 6 is a constant, so if I differentiate 6, I'm going to get 0. So I'm going to put here the y dx equals, I'm going to use the last rule here to differentiate this. So remember, I'm using term-wise differentiation, which requires to differentiate each term. So 3 times 8 is 24. X comes down, 3 minus 1, subtracting 1 from the power gives you 2. Minus 2 is the power here. 2 times minus 5 is minus 10. X, subtracting 1 from the power 2 gives you 1. And x raised to the power 1 is x. 6, differentiating 6 gives you 0 because 6 is a constant. So when you differentiate 6, it gives you 0. So it means that differentiating this function in 13 gives us this result as our dy dx. It's as simple as that. Now let's go over to question 14 without much waste of time. So in question 14, I'm going to be introducing you to what you may know already, and it is called the quotient rule of differentiation. So we are given this in question 14 to solve. Okay? In question 14, we are asked to do this. If y is equal to this function, then what is the y dx? Okay? What is the y dx? So let's come over, let's wipe this off. So let's wipe this off quickly and solve problem 14. So I'm going to be using a rule called product rule to solve problem 14. So guys, you may ask the question, what is product rule of differentiation? And when do you use product rule of differentiation? How would you look at a problem in differentiation and tell that this problem requires the use of product rule of differentiation? So, how do you tell? How would you know? Okay? So we shall be looking at that problem immediately. Let's look at that problem immediately. Okay? So, let's see. So for problem 14, we are given this. I'm going to bring it over here. Y equals x minus 3 and x plus 4, a product of two functions. So, looking at it critically, I could call this function u and I could call this function v. Okay? So all I have to do is to say let u be equal to x minus 3 and let v be equal to x plus 4. Okay? So please take note, if that is possible, it reduces the problem to u times v. And if y is equal to u times v, a product of two functions, if you can express a function y as a product of two independent functions, say u and v, with y, u and v all dependent on the same independent variable x. Take note, y depends on x through these functions and the functions depend on x directly. Okay? So x is the independent variable, y is the dependent variable, u and v are also independent variables relative to y, but dependent variables relative to x. So if y is equal to u times v, then it follows that the y dx can be obtained using what we call the product rule, v du dx plus u dv dx. Meaning that in product rule, all you have to do when y is equal to a product of two functions u and v is to keep the first one constant and differentiate the second one. Add your result to keeping the second one constant and differentiate it, the first one. So you will come over here and do this. So I'm going to do this. Now, u equals x minus 3 implies that the u, the x, using those rules I gave earlier on, is 1. Okay? So differentiating a constant gives you 0. So differentiating 3 gives you 0. Differentiating x gives you 1 because the coefficient is 1. Okay? Now, similarly, v is equal to x plus 4. If you differentiate x plus 4, that is, differentiate v with respect to x, you are also going to get 1. Now, why is that so? Please take note. This is the same thing as 1 and coefficient 1. 1 times 1 will give you 1, and 1 minus 1 will give you 0. So what is actually going on is this. Okay? So 1 minus 1 is 0 and x raised to the power 0 is 1. 1 times 1 is 1. So when you differentiate these, you will end up getting 1. Similarly, you will get 1 for this. Now please take note. Once you've differentiated, we've called u this and you've called v this function, then differentiating them will give you that. As such, you can now implement product rule of differentiation. So what would the y dx be? The y dx will now be v, which is x plus 4 kept constant, times the u dx, which is 1, plus u, which is x minus 3 kept constant, with the v dx, which is 1. So if you simplify, that will give you x plus 4. X plus 4 times 1 will give you x plus 4, plus x minus 3 times 1, which is x minus 3. So this and this would add to each other to give you 2x, and you end up having 4 minus 3, which is 1. So the y dx for that particular function will give you 2x plus 1. Now, okay, now let's move over to question number 15. Question number 15 demands that we do the following. It wants us to find, so question number 15 gives us this function x raised to the power 4 minus 3x cubed minus 4x squared plus 5 all over x squared. And we are asked to find the y, the x. Now, in the previous question, question 14, we used what we call quotient rule, product rule of differentiation. In this kind of problem, we shall be using another technique called the quotient rule of differentiation. Why? In this case, notice that two polynomial functions are expressed as a ratio to one another. That is, one function in the numerator over another function in the denominator. So, what we are going to be using is called quotient rule of differentiation. So we are going to be using quotient rule. Now the question is, under what circumstance do you use quotient rule? Now quotient rule states that if y, a function, a dependent variable, depends on x through two functions expressed as a ratio u and v, such that y is dependent on x indirectly through u and v, meaning that u and v are dependent on x directly. Then according to quotient rule, provided v is not equal to 0, the y dx will be equal to v du dx minus u dv dx all over v squared. Okay? So, according to quotient rule, all you have to do is to use the denominator to multiply the derivative of the numerator and subtract from that result the product of the numerator times the derivative of the denominator all over the square of the denominator. So what I'm going to do here will be to start with calling for this particular function we've been given. I'm going to call the numerator and denominator different functions. Okay? So I'm going to do this. I'm going to do this here. So I'm going to say let u be equal to my numerator x raised to the power 4, 3x cubed minus 4x squared plus 5. And I'm going to say the u dx, therefore, when you differentiate this, will give us 4 times the coefficient 1 here gives us 4. X raised to the power 4 minus 1 gives us 3. 3 times minus 3 gives us 9. X raised to the power 3 minus 1 gives us 2. Then you have minus 2 times minus 1 gives us 8. 8 raised to the power x, 2 minus 1 gives us 1, which is x. And differentiating the constant gives 0. So I've obtained the u dx. The next thing you have to do is to call v the denominator, so v is equal to x squared from that problem. Okay? And the v dx will be equal to 2 times 1, the coefficient, giving us 2x. Subtracting 1 from the power gives us 1, so that will be 2x. Okay? Now, once you are done getting these results, you can now say, therefore, the y dx will be equal to, according to this, v. What's your v? You bring it here, x squared. What's your du dx? It says v times du dx, so you bring your v, x squared, multiplying your du dx. Your du dx is this, 4x cubed minus 9x squared minus 8x, close bracket, then minus u. Your u is in bracket x raised to the power 4 minus 3x cubed minus 4x squared plus 5. okay, plus 5 times your dv. Your dv is your v rather, yes, your dv dx is 2x. So I will bring my 2 here and put here x, okay, all over v squared, and your v squared will be whatsoever v is, which is x squared all squared. So that simplifies to give x squared multiplies, opens up this bracket to give us 4x raised to power 5. X squared multiplies minus 9 to give us minus 9x raised to power 4. X squared multiplies 8x to give us minus 8x cubed. Minus 2 opens up this bracket times x gives us minus 2x raised to power 5. Minus 2 multiplies this to give us plus 6. Then x multiplies x cubed to give us x raised to power 4. Now, x multiplies this to give us 4x cubed. 4x cubed minus 4x cubed times minus 2 give us plus 8x raised to power 3. X times 5 is 5x times minus 2 give us minus 10 all over x raised to power 4. So this is the y, the x. Now, you can simplify by taking like terms. So let's simplify to get the final result. 4x raised to power 5 minus 2x raised to power 5 will give us 2x raised to power 5. So I've handled this and I've handled this. Then we have minus 8x raised to power 3 plus 8x raised to power 3 would go to give us 0. Okay? Then minus x raised to power 4 plus 9 plus 6x raised to power 4 will give us minus 3x raised to power 4. Then comes the final term there, which is minus 10 all over x raised to power 4. So if you differentiate this function, the function we've been given in problem 15, you will get that result. So please verify and drop your comment in the comment section. Now, that being said, please, I'll be expecting to see questions and reactions to what we've done here. In case there's an oversight, please do well to drop your comments in the comment section. Tell us how you feel about what we've done. Tell us what you've observed from what we've done, okay? I would really appreciate that. It leads to knowledge. Thank you very much. So, welcome Debbie Smile, Charlie Okon, Prosper. I can see you all, Sylvia, and of course, my darling Mary Grace. Welcome. Now, let's see. Debbie, darling, I hope you're smiling. Let's see problem 16. So for problem 16, we have y equals square root of x plus 1 over square root of x, and we are asked to find the y dx. So how do you find the y dx in this case? Please take notes. You could simplify, you could start with simplifying the function. In this case, you could differentiate term by term, or you just start with simplifying the function. For this problem, I'm going to do this. So I'm going to write square root of x, I'm going to write as this, and I'm going to write this as x raised to power minus half. Now, where is this coming from? Please take note. This is coming from, for the second term, take note that the square root of a is a raised to power half from indices, okay? And 1 over a raised to power n from indices is a raised to power minus n. So what I have done here is to say 1 over square root of x, which is 1 over x raised to power half. Now, using the second law of indices, this second law of indices, it now translates into this. So, once you can do this, the problem is simple to differentiate. So, you can now use the rule we used earlier on. That is, if you can simplify or rewrite this function as this, you can now use this law that says if y equals ax raised to power n, the y dx will be an x raised to power n minus 1. So you can use that law. So and that's what I'm going to be using here. The coefficient here is 1, the coefficient here is 1. So half times 1 is half, x raised to power half minus 1. Plus, the same thing, minus half times plus 1 will give you minus half, x raised to power minus 1 over 2 minus 1. So you end up having this to be 1 over 2 x raised to power half minus 1 is minus half. Okay? And this will give me half x raised to power minus 3 over 2. Take note, minus half minus 1 is minus 1.5, which is the same thing as minus 3 over 2. So at this point in time, you can now rewrite the problem as 1 over 2 raised to power 2x raised to power half, according to this law of indices, okay, minus 1 over 2 also x raised to power 3 over 2. And that gives you 1 over 2 square root of x using this law of indices, and this one gives you 1 over 2 square root of x raised to power 3. And what law have I used here? This law of indices that says a raised to power m over n is equal to the nth root of a raised to power n. That's the law I have used there. Okay? So if you differentiate y, which is given as this, be expressed as this, you would end up getting this result. And of course, every other thing is yours to do. It is simplification. Okay? So you can simplify to get a final result. If I want to simplify further, I could make this result look like this. Half in bracket 1 over square root of x minus 1 over square root of x cubed. Okay? So, what problem are we to solve next? We have to solve problem 17. If we can get to problem 20, I'll end the class. It will be a proper way and a proper point to end. So let's go to problem. Please, and please, after this class, go over the video from start to finish, taking it steadily, probably in slow motion. You could go over it again and again just to understand what we've done. And if you have any question, please feel free, do well to drop your comments in the comment section. I will see them and I will react to them. Thank you very much. And thank you for staying patient in this class despite every network challenge we had experienced earlier on. So let's go over to problem 17 quickly. Now in problem 17, we are given y equals 2x plus 3 all raised to the power 4. And we are asked to find the y dx. Now please take note, for a problem like this, you would be using, or you should be using, function of a function. Okay? The rule of function of a function to solve the problem. The rule of function of a function leads to chain rule of differentiation. And it is applicable when you have a function embedded in another function and it goes on like that. Okay? So what I'm going to do here to this problem is to say, let u be equal to the inner function 2x plus 3. So this is more or less the child function. Okay? So if you consider 2x plus 3 to be a child function embedded in y, then the problem y equals u raised to the power 4 is now like a mother function. Okay? So what rule do you use in function of a function? The rule is differentiate. If I'm to get the y dx, then the rule will be differentiate mother function times differentiate child function. It's as simple as that. So differentiate the mother function and multiply your result with the child function, the derivative of the child function. So we are going to apply that rule here. That rule translates to dy du. The mother function now looks like y equals u raised to the power 4 because we've called 2x plus 3 u. And the child function is u equals 2x plus 3. So if you differentiate the child function, you will be differentiating u with respect to x. So what would we get? Now, differentiating the mother function, if you differentiate y equals u raised to the power 4, you end up having 4 u raised to the power 3. That is 4 multiplies the coefficient 1, gives you 4. Subtract 1 from the power, it gives you 3. Times differentiating the child function u with respect to x, you end up having 2. Okay, because differentiating 2x gives 2 and differentiating the constant 3 gives 0. So once you get this, you can now write your result as 8 u raised to the power 3. And what is u, guys? U is 2x plus 3. So at this point you can reintroduce your child function and all raised to the power 3, and that gives you your result. It's as simple as that. Please, you don't even need to touch pen on this question. You can actually give the result simply by just following this rule. Differentiate mother function and multiply your result by child function. So if the function extends beyond two functions embedded in one another, then all you have to do is, if it is three functions put together, you can now say differentiate grandmother function, multiply the result with differentiating mother function, multiply the result with differentiating child function, and it is called chain rule because the chain continues. Now, let's move over to question 18. Let's move over to question 18. I'm going to be giving out my shout out to people who have made this video very possible. Excellence. I want to give a very special shout out to Excellence, who has made this class possible through encouragement and every other thing. I want to say a very big shout out to Prosper also, and to those of you I'm seeing, Mary Grace, my darling, Sylvia, my baby, and the rest of you, Chayoko, my friend, and who else am I seeing there? Rimaka, welcome, and I'm also seeing Debbie Smile, my darling. So I want to say a very big shout out to all of you for staying put to watch this video. Let's go over to question 18. I'm seeing Rimaka there from India. Thank you very much. I'm going to say, please, guys, say a very big welcome. I want all of you to say a very big welcome to Rimaka from India joining our live class. Welcome. You'll be the first foreigner I'll be having on my live session. Please welcome. Tell your friends about the class. Like the video, share the video, and subscribe to the channel if you haven't subscribed. I really appreciate you, Rimaka. Welcome to Nigeria. We're in Nigeria staging this class, so welcome. So let's go over to question 18. In question 18, we are given this. We are asked to differentiate this function y equals 1 over 3x squared plus 1 all raised to power 3. Now, please take note. What are we going to be using to solve this problem? With what would we be solving this problem? We shall be using, let me take a pause at this point to explain something. Please take note, in solving a particular problem, in differentiating a particular function, you may need more than 2 rules or more than 1 rule of differentiation. Please take a good look at this problem. There are so many ways I could go about solving this problem. One student may decide to use quotient rule to solve this problem. You'll get the same result. And of course, you won't be wrong, because using quotient rule to solve this problem would be you expressing the function as u over v, in which case u is 1 and v is the denominator. Now, please take note, that would be one way of solving this problem. Another way of solving this problem could be you using indices, that is, using this law of indices to simplify and then solve the problem using function of a function. And that's the one I'm going to be using. Okay? So what I'm going to do here is to call this function, rewrite this function using this law of indices as 3x squared plus 1 raised to power minus 3. Okay? I'm going to use this law of indices and apply it to the problem. So I'm going to re-express this function as this. Now, once I've done that, I'm going to say there is a child function, obviously. The child function is what is inside the bracket, 3x squared plus 1. And I'm going to say, let u be my child function. So u will be equal to 3x squared plus 1. Okay? So it now means that y, which is my mother function y, will now be equal to, if I'm calling my child function u, so y will be equal to u raised to power minus 3. So, according to chain rule of differentiation for two functions, the y, the x, if one function is called, if the child function is called u and the mother function is called y, then the y, the x will be the y all over the u times the u, the x. And that would mean differentiating y with respect to u means differentiating our mother function. And our mother function is u raised to power minus 3. Differentiating y with respect to u would give us minus 3 multiplying the coefficient 1 here gives us minus 3. Subtracting 1 from the power, minus 3 gives us minus 4. So minus 3 minus 1 gives us minus 4. Times differentiating the child function will now give us the u, the x. And what is the child function, guys? It is 3x squared plus 1. So if we differentiate 3x squared plus 1, 2 would multiply 3 to give you 6. Subtracting 1 from the power leaves you with x raised to the power 1, which is x. Differentiating the constant term gives you 0. Okay? So you end up having your result as minus 3u raised to the power minus 4 times 6x. And here you can now multiply 6 with minus 3 to give you minus 18. And you can put as what you had it to be, 3x squared plus 1. So I'm going to put 3x squared plus 1 to replace u. And I'm going to put minus 4 here as the exponent in that bracket or to that bracket times x. So this can be rewritten as 18 minus 18x all over. When I bring this using this law of indices, it becomes 3x squared plus 1 raised to the power 4. And it solves that problem. So that is one way to solving the problem in question 18. Now let's go over to question 19 before we round up our live session in question 20. Okay, so let's go to question 19. Now, for question 19, let's see what we are asked to do. So, in question 19, we are asked to solve the problem. We are asked to solve this problem. We are asked to differentiate this function 4x cubed plus 2x raised to the power half. We are asked to do this. So we are asked to find the y, the x. So what is the y, the x if you are given this? Okay? What is, thank you. I'm so happy to see you. I'm so happy to see a foreign student in our live class. Remaka, please, every day we have this class. We'll be having this class, our classes every day on different topics in mathematics as well as in statistics. Thank you for joining this class. I am humbled by your presence. Welcome. Please tell your friends in India, tell your friends in neighboring countries, if you have such, to join our live classes where we interact. Feel free to ask questions. Feel free to engage with us. Drop your good comments in the comment section. I am so happy to see you. I love you from Nigeria. I'm giving you Nigeria love. Okay? So welcome to the class. I'm giving you Nigeria love. So all of us from Nigeria, we say welcome to you and we love you, Remaka. So welcome. So let's move over to solving question 19. So let u be equal to 4x raised to the power 3 plus 2x. So the u dx will be equal to 12x squared. Okay? So how did we get 12x squared? 3 times 4 is 12. 2 minus 1, 3 minus 1 gives you 2. And differentiating 2x gives you 2 because this is a linear term. Okay? Now, I'm going to, since we've called u the child function, so this is my child function. Your mother function will now be, mother function, in this case, will be equal to y, which is equal to u raised to the power half. Okay? So the y, the u will be half times u raised to the power half minus 1, which is half u raised to the power minus half, which is 1 over 2 square root of u. Okay? So if you differentiate the inner function, you will end up having 12x squared plus 2. If you differentiate the outer function, which is the mother function, you end up having, you have to differentiate y equals u raised to the power half, which translates to this, using our procedure for differentiation. So what is the y dx? That which we are interested in, it is the y du times the u dx. So what is the y du? The y du gives us 1 over 2 square root of u. What is the u dx? The u dx is 12x squared plus 2. So this is 12x squared plus 2. Now, this simplifies to 12x squared plus 2 when it multiplies 1, the numerator. Of course, you know this is over 1. All over 2 square root of what u is. And what is u, guys? U is 4x cubed plus 2x. And that is the derivative we want. Now, finally, before I say very good night to all of you, let's see, Sylvia. Okay, thank you all for saying welcome to Remaka. Thank you. Please show him some love in the live chat. Show him some love. Okay, do well to show him some love. I don't know if I'm talking to a female. Remaka, are you a female or a male? Okay, Sorry, I don't know your gender. Please, whatsoever your gender is, we appreciate you and we say welcome to our live chat. So now, so we shall be continuing this class tomorrow. In tomorrow's class, we shall keep on solving our problems on differentiation and eventually, before the week runs out, we'll be going into integration. Okay. So let's see question 20 or question 20. So we are given this y equals 4x cubed plus 2x squared plus 5. I love this question. You are asked to find y. Okay, you are given this f of x equals this function, and you're asked to find f prime of x, f prime of 2. Now, what is the idea for solving a problem like this? Please take note. If f of x is a function such as 4x cubed plus 2x squared plus 5, then another way of representing the derivative of f of x, is to write it as f prime. So if I don't want to use, let's say we have a function f of x, y equals f of x. The y dx is the same as f prime of x, the first derivative. Okay? So, what is the idea for solving a problem like this? Now that we are rounding up our class, all you have to do is to find f prime of x first. Please take note, don't be confused. F prime of x is the same thing you already know. It is the y dx, the first derivative of that function. So, do what you know already. If you differentiate this function, it will give you 3 to the power times 4, giving you 12. 12x squared, because subtracting 1 from the power gives you 2. 2 times 2 gives you 4. This will give you 4x, because subtracting 1 from 2 gives you 1. And differentiating the constant gives you 0. So when you find the derivative of this, that is f prime of x, which is the y dx, it gives you 12x squared plus 4x. Now, take note please. The question did not say find f prime of x. The question said find f prime of 2. So f prime of 2, please take note, is the value of this derivative 12x squared plus 4x when x is equal to 2. So once you've been able to obtain f prime of x, you can now go ahead to find f prime of 2. What would you do to get f prime of 2? Put 2 in place of x in your derivative. So I'm going to do this. 12 times 2 raised to power 2 plus 4 times 2. And that will give me 12 times 4, which is 2 squared plus 8. And 12 times 4 is 48. 48 plus 8 gives me 56. So this will be the final answer to that problem. I love you all, I love you all, and I love you all from every part. Okay, Rimaka is saying he or she is a 12th grade student. Welcome, Rimaka. I'll be seeing you in tomorrow's class. Tomorrow, Nigerian time, we start by 7:30. Please, if you have colleagues of yours in 12th grade needing this topic, this particular class is all about solving problems in differentiation. Eventually, we'll be going into solving problems in integration, applications of differentiation, applications of integration. We'll be going into solving problems in two-dimensional rectangular Cartesian and problems on conic sections, all in a topic or a course called in Nigeria Calculus and Analytic Geometry. So we are currently looking at a course called Calculus and Analytic Geometry in Nigeria, okay? Otherwise, regarded as General Mathematics 2 in the school I teach. So please tell your friends in 12th grade in your class in India that a class like this is going on in Nigeria, but we welcome everybody from all over the world to join this live class. So we'll be back again by 7:30 tomorrow, between the hours of 7 and 7:30 tomorrow. Tell your friends, I hope to see you. I really appreciate you, and I hope to see you in tomorrow's class. To all my students in Nigeria, I say a very big thank you to you, because at first we experienced so many network challenges that came our way that nearly stopped this video or this class from holding, but we became victorious. Thank you for joining the live class. Do like the video, share the video, drop your good comments after looking at what we've done today, and I'll be seeing you in my class tomorrow. Good night, and I love you all.